Here we are going to discuss the steps with regards to the critical value or classical approach for a z-test for population mean mu. Here's a symbol for population mean. It's a Greek letter called mu. So the first step is to translate the stated hypothesis or claim in mathematical or symbolic form. So let us go to weekly notes number 9. To do that, go to your Gmail account and you can go to a new tab. We are going to look for an example. Go to Google Apps, go to Classroom, go to create or join a class, go to join a class, and type in the class code CI3QYBO. By now you should be familiar with this class code. Join, then go to classwork, and go to weekly notes number 9. You have it in Word, PowerPoint, and you have it in video format. Let's click on the PowerPoint format. Weekly notes number 9. And we're going to get an example of the steps with regards to a z-test for me. So here's the example number 9.1. It's a z-test for two-tail. Z-test for mean is a two-tail test. And as you can see, the first step is where the hypotheses have to be translated to symbolic form. And the hypothesis here has been identified as is 9405. That phrase, the mean is different from 9,405. Here it is. So that's the claim. So this has to be translated to symbolic form. The mean is 9,405. And the mean is not 9,405. It's different from 9,405. Here's the symbol for mean, which is mu. And the symbol for is the equal sign. So here's the translation to symbolic form. Now we've got to identify if this claim is a null or an alternative. So the alternative does not carry the equal sign. The null always carries the equal sign. That's the rule. The third step is to complete the pair. So there are 3 pairs that can be completed. Either you have a right tail, a left tail, or a two tail. It all depends on the sign of the alternative. It says, remember, for the z-test for me, the rejection region or the tail will always follow the sign of the alternative statement. So if the sign is pointing towards the right, you've got a right tail. If the sign is pointing towards the left, you've got a left tail. And not equal, you've got a two tail. So the symbol for the null will be opposite to that of the alternative with the equal sign. So if the alternative is pointing towards the right, the null will point towards the left with the equal sign. If the alternative is pointing towards the left, the null will point towards the right with the equal sign. And if the alternative is the not equal sign, the null will have the equal sign. And here's a table to help with that completion. The fourth step is to sketch a distribution curve. The distribution curve will be a bell-shaped curve. It will be a normal curve. Here it is. The fifth step is to locate and shade the critical region. So your test for the z-test can either be a one-tail or a two-tail. One-tail is in one direction, two-tail is in both directions. So remember, for the z-test forming, the critical region always follows the sign of the alternative statement. The sign of the alternative statement can point to the left or right or both directions. It all depends on the sign of the alternative statement. That is how you will know what tail your test will be. Right, right tail. Left, left tail. Not equal, two tail. Then the sixth step now is to place the critical value on the critical point. And the seventh step now is to calculate what you call a test statistic. Here's the formula for the z-test statistic. And the eighth step is to plot the test statistic on the distribution curve. You must look to see where the critical value is, because the curve will already have the critical value, and you will plot the test statistic in reference to that critical value. And step number 9 is decision time. So you reject the null hypothesis if that test statistic is in the critical region. That test statistic that was calculated, if it lands in the shaded region, that is when you reject the null. Or if it does not land in the critical region, you do not reject the null. So if your test statistic does not land in the critical region, if it lands in the unshaded region, you do not reject the null. So your decision is either to reject the null or do not reject the null based on where your test statistic landed. And step number 10 now is conclusion. So if you had rejected the null, then you are left with the alternative. So the alternative will be the conclusion. But if you did not reject the null, then that null itself will be the conclusion. So always remember that you will start the test with two statements, the null and the alternative. After the test is done, only one will be the conclusion, and you have to write it in worded form. So if you rejected the null, then you have to conclude with the alternative statement. If you did not reject the null, then you have to conclude with that null statement. And you can follow on this example here in weekly notes number 9. Example 9.1. Here it is. Here are the steps. Example 9.2 is another z-test formula, left tail. And example 9.3 is another example, which is a right tail.